Well, for RCR Tech, my name's Sean Kinney, and welcome to Signal and Noise, where we host conversations from the edge of AI with a range of industry experts and thought leaders. It's a pleasure to welcome to the show Mr. Vish Nandlall, who tells me he is semi-retired following his tenure most recently at Dell Technologies. So, Vish, thank you very much for taking the time to join me.
Thanks for having me, Sean. I'm looking forward to the discussion.
So for everyone in the audience, you need to follow Vish on LinkedIn. He's publishing some very thorough, thoughtful, forward-looking analysis of a range of topics, but the one we're going to focus in on today is this recent framing of AI as a study in paradoxes that you put out. And I guess the best way to do this is just one at a time. So maybe let's start with this relationship between training and inference costs. I think for a training run for a frontier LLM, we're talking hundreds of millions of dollars, whereas on the inference side, we're seeing all these system level efficiency gains that are just causing the cost to serve inference plummet. We're thinking single digit cents for 1,000 tokens, which is roughly and will obviously vary depending on the model. But I mean, as you characterized it, efficiency is the new moat here in this paradigm. So, what does that mean for a usage-based billing model when that price increasingly approaches zero?
Yeah, I mean, it's an interesting paradox. We've got this regime that we've somehow steered ourselves into where we have really intelligence for zero marginal cost, but we have massive fixed costs. And it's one of these interesting paradoxes that we stumbled into, and it has implications, I think, for the software industry. I mean, when you have effectively zero cost to add intelligence to a particular application or service or process, we're entering in, steering ourselves into an era where every company has to be an AI company. I think about, initially when Adobe, confronted this reality of, Mid-Journey and ChatGPT being able to generate images at pennies, it provided an existential threat to this company. And the absolute worst response would have been, I'm going to create video generating or image generating engine that would cost me less. Instead, what they did is they realized that image generation was just part of the process. The creative process had a number of different elements that if they could integrate that intelligence into it, they would still be able to get a premium because things like, brand management, things like copyright infringement, all these things had kind of real world consequences for the companies that were using these types of services. And if they integrated into their application suite, they were going to create an advantage for themselves. And I think, I see the parallel happening all over the place. I am kind of retired, but I get to use a lot of new tools. I'm outside of the Microsoft ecosystem and I'm using tools like Notion. If you go into Notion, really AI is kind of front and center. It doesn't cost a premium. They just recognize that this is just something that you have to be able to leverage as part of my application. If I look at companies like Shopify here in Ottawa, where I live, they've integrated AI into almost every layer of the Shopify experience. And again, it's not a premium; it's just a matter of fact capability that that they have access to zero cost. So why not take advantage of it? And so I think we're starting to see this inversion of economics happening, which is spurring on the adoption of AI.
Yeah, I mean, I think your characterization in the Adobe example of an existential threat, I mean, that's exactly right. And they fortunately had the operational ability to pivot and to take advantage of the moment rather than become victim of it. But if we
Right.
look at the software side to the infrastructure side, what does this training inference economic reality mean for infrastructure owners? It seems like these are the long-term winners here, right?
Yeah, I think there's infrastructure at different levels. There is, I think, going to be a race to understand, well, where's the value capture in AI? There's billions and billions of dollars being poured into this. I feel like I start to watch this show on a well-known streamer called The Gilded Age, and it's all about the robber barons. And I kind of feel like we're in the robber baron era for AI. People are spending massive amounts of capital to acquire H100s and build out data center infrastructure. They're vertically integrating. Some of these are, forming consortia in order to have not just access to the infrastructure, but the foundational models themselves. So it's kind of an interesting time. The importance of what happened during the Huawei Barons era and even another kind of a massive technology inflections that we've had all the way from, the industrial era to the internet era has been to try to understand, well, where is the value going to be created in the middle of all this? And I think there's still opportunity to get premiums. I do see an emergence of latency and reliability premiums. So it's not really just about speed, but if you could, have sub 100 millisecond response times, you're able to, likely generate a 10 to 100x pricing premium over just standard inference. And it's about the user experience and the workflow integration. So if you're vibe coding using a Copilot, a developer is going to pay for a premium to get an instant suggestion that doesn't kind of break their vibe. If you're, a customer service enterprise like Zendesk, companies are going to pay 10x more for AI that can respond instantly to customer queries. And this goes on and on. Financial trading algorithms, you can see it, kind of as a relevant reality. The other area over latency and reliability I see is the specialized model endpoints. So this is where you have models that are going to be trained for a specific application for a domain. And these aren't going to be replicated by general purpose alternatives. So you can think of, if you're using ChatGPT and you want to take on Rust specific tasks, if you had a codex that was trained exclusively on Rust, it's going to outperform GPT-4 or GPT-5. If you have a medical imaging model, I'm thinking of RAD AI's model. It's trained on millions of medical images, and they had radiologists do the annotations. So you can see this pattern developing on specialized model endpoints where, the proprietary data sets that competitors can't access are creating that sustainable competitive moat. I think the more interesting one that, you should see if you've ever interacted with a tool is I guess I'm going to call it the integration orchestration layer. It's that middleware that actually makes AI useful. It connects AI capabilities to an existing business process. So you can think of like Salesforce Einstein. It's not just AI predictions, but it's AI integrated into that workflow. So you can get automatic lead scoring, opportunity analysis, sales forecasting, all of these wonderful things that, start to add value to a particular enterprise. And it creates this network effect. The winners aren't just the infrastructure owners. They're the companies that are going to bundle that infrastructure with irreplaceable data moats, specialized model architectures, and integrated experience. So it's not so much a race to the bottom, but a race to the most differentiated vertical experience.
Certainly. I mean, business clarity, what is my goal? How do I achieve that goal in the most efficient manner possible? It's probably not while also pursuing super intelligence.
That's right. Exactly right.
All right, so your second paradox was the underdog story, right? And this, flows
Yes.
naturally from what we're discussing here around infrastructure owners, but you described Oracle as a kingmaker in the AI arms race, given their control of data center capacity. How do you think this plays out over time? I mean, obviously they're seeing the financial rewards from this, in real time, quarter over quarter is very impressive. Congratulations, Oracle. But, is this a durable strategic advantage or is this sort of a short-term stopgap until the hyperscalers, continue to deploy capital, continue to stand up data center capacity, and they kind of figure out that co-opetition model that you would maybe
Right.
in Microsoft and OpenAI, for instance. So just kind of what do you expect over the next few years?
It's a fascinating story. Oracle kind of came out of left field for me. I certainly was more fixated on what AWS and what Google and what Microsoft was doing. It's fascinating because you've got this perfect storm of supply chain constraints meeting this explosive AI demand. And Oracle suddenly steps into this fray, and suddenly people are recognizing them as a powerhouse in this. And when you look deeper, there are some underlying assets that Oracle has that they're taking advantage of, and I think it's going to give them a window of opportunity. The first is a lot of people tracking Oracle's entry to the public cloud space. They came late, and it gave them an advantage because most of the hyperscalers started in 2006, maybe 2000 or 2014. Oracle came in around 2015, near the tail end of a lot of the buildouts. And so they purpose built a lot of their data centers to handle much more of a heavier power load. And they did it for a couple of reasons. One is that they could. They had a little bit more foresight in terms of building for future-facing capacity. But when you take a look at Oracle offers, one of their key clusters is their Exadata cluster. And if you look at the density of that, it has densities that are very similar to GPU densities. So they had, these rack scale architectures that could cool, 50 to 100 kilowatts, whereas, the hyperscalers were building to 10 to maybe 20 kilowatts. And so, they're coming in with power density that could really, house an H100 GPU cluster fairly easily without requiring some massive power upgrades. And so, you think of, to build a new data center with the adequate power takes about 3 to 5 years because you need electrical grid connections, transformers, cooling systems. They've got all those assets. So it kind of gives them, a baked-in advantage. And, the other area that I think is pretty, helpful for them is that they do have, this customer lock-in because a lot of customers have databases that run on Oracle products. And there's some unique advantages there. When you think of an enterprise that wants to run AI on their data, Oracle has this integrated solution that doesn't require you to do data migrations. So if you have real-time analytics or compliance and governance issues, legacy systems, a lot of those things can stay intact while Oracle just layers on this new AI story on top of it. It's compelling. I could, talk about a lot of different enterprise customers who are looking to, build a little AI unicorn blood on top of their digital assets. And if they want to make that migration, they may have to spend $50 million in 18 to 12 months doing the data migration, whereas with Oracle, it kind of happens out of the box. So they've got, I think, that enterprise integration into the IT stack that gives them some stickiness. And the other thing that I think is interesting about Oracle is that, because they're a bit of a left field player, they have a slightly different strategy than the hyperscalers did. That they're really well positioned for what I'll call the sovereign AI play. They have much more flexible systems around data residency requirements. They're not perceived as so politically aligned with US foreign policy than, let's say, Amazon, Google, or Microsoft. And most national databases are running on Oracle infrastructure. So adding AI capabilities kind of becomes a natural extension versus, a whole separate technology project. So you kind of look at all those things and they do have these durable advantages that they are a competitive player and I think will rightly keep their place. Having said that, I don't think it's a big window. I think they got like a 3 to 5 year window maybe. Like I said, they do have advantages that give them a bit of a capacity play and a stickiness play, but the hyperscalers are coming. These guys are building purpose-built AI data centers. They're spending hundreds of billions of dollars in capital to make it happen. They've got custom silicon, they have global scale advantages. And I think probably more importantly, they're actually building out an edge compute evolution versus what Oracle had done. Oracle definitely consolidated into large regional data centers, didn't really look into tier two and tier three cities, and didn't look at building out more edge infrastructure that was closer to where the data is. And when I think of that evolution, I do see that there's a structural advantage that a lot of the hyperscalers have. And I think that could turn the tide. And we'll see what Oracle does in terms of extending their current position to take advantage of some of these shaping realities in the AI landscape to actually build out to meet them. So I don't think that they have a permanent moat. They've got a unique period of supply demand imbalance, but their success is really going to require them to evolve opportunistically well beyond just capacity provision. They got to invest in the stack.
Yeah, when I look at this kind of world of neo clouds, not really a term I love, but
Yeah.
really curious what is happening 10 years from now. Like, where is CoreWeave in 10 years? And kind of
Yeah.
just, I really don't have a good feel for it.
It's such a shift in the competitive dynamics. If I think of like a Google or an Amazon, their advantage comes largely from scale. Because if you take a look at, the cost per month, let's say, the cost per month to run a data center between capital and OpEx is pretty well balanced. Buying a server, it's, a $20,000, $15,000 issue. And if you look at the aggregated costs for, doing the maintenance on top of that, it's about the same. If you do the, take a 5 year window or some or a 3 year window and amortize out the cost of the capital. So when you look at that OpEx, that's where Google and Amazon, they, feast on that. They get enough, they've got a way to batch out a lot of the jobs that are required to really take advantage and get a, some level of arbitrage out of that OpEx line item. When you look at AI and GPUs, if you want to buy an H100 cluster, it could cost just for like eight, somewhere around 250K. So the capital cost suddenly becomes a dominant pool. And so that relative OpEx arbitrage that the hyperscalers are so good at, they don't really have an opportunity to take advantage of that. So it's a cost basis. And so companies like CoreWeave and others, they've been driven to cost of capital as really the motivating advantage here. So if you can get low cost of capital, or if you've got a fairly nice financial spreadsheet, then everything works out well. Things are a little bit difficult now. A lot of these companies like CoreWeave are funded by deep financial pockets, and that's what Facebook and everyone else is competing on. And that levels the playing field. So companies like CoreWeave and others can really kind of get in there. That's why we're seeing all these little Neil clouds kind of pop up. And I think to your point, it's what's the thing that's going to be sustainable to them? And I think, they have long-term supply commitments that they've got with TSMC and with NVIDIA in particular. So that, those supply guarantees are important and they're baked into some of their business models. So they got an advantage in terms of access to the thing that's powering this revolution. And it's these, kind of non-technical almost advantages that are starting to become dominating. It's not necessarily how clever you are in terms of reducing the OpEx and using Moore's law to grind away at the dollars. It's how good are you at accessing capital? How good are you at creating master service agreements with some of the larger chip vendors? How quick are you to be able to kind of put up private equity types of arrangements where everybody gets their interests served well? It's kind of more financial management more than anything else. I think to your point, it's the guys who are really good at that financial wizardry that are actually going to be able to sustain, something over the course of time.
Your comment about custom silicon, I think that's going to prove very important over the long term. And I also have a distinct feeling that we are collectively going to learn a lot about GPU depreciation schedules.
Yes, I think exactly right. I mean, the magic behind a lot of the custom silicon, if you look at Google's TPU, is you have the opportunity to really focus on system costs and how does the silicon plus the network, plus your ancillary compute and storage, how do they all work together to drive the lowest cost? And, Google's been famously very good at doing this. Microsoft less so because they're dealing with H100s and they're basically running the NVIDIA playbook. Amazon's got Trainium, although they do a lot of work on H100s as well. Are they getting a cost advantage? Time will tell. But I do think that there is opportunities for maybe further economic arbitrage using custom silicon. And if you can get architectural improvements through them to really beat down the door of some of the bottlenecks at an architecture level, you could create an advantage. It's really the question of how long and how durable silicon cycles are. You put a lot of money into it before someone else who's following the industry power curve of an NVIDIA comes up with a new architecture that's better and they have the economies of scale to distribute it and make the per unit cost lower. It's hard to compete against those machines that serve many versus a machine that only serves yourself.
That's very well said. And returning to your paradoxes, the third one is this measurement paradox. I was just before this call looking at a table comparing model performance against a number of, just industry-wide benchmarks. And I looked at it so long that it became utterly meaningless, and I feel like the pace of change is such that point in time benchmarking just kind of doesn't really convey that much actual useful information to me. So I'm just kind of curious to hear from you, how do we need to be thinking about measuring performance? And I would also ask you to kind of relate that to your earlier comment about user experience. I look at these benchmarks, they're not relevant to me as an end user. They don't do anything to define the experience I have, the accuracy I have in a particular tool versus another, the trust that I've developed over time using it and seeing reliably accurate outputs and so forth. But just what do we need to do about measurement?
Yeah, this is such a big question. I think it's actually one of the foundational elements for how this industry is actually going to move forward is to get benchmarking right and to get measurement in particular right. To your point, I'm on LinkedIn quite often, and you'll always see people comment about, Claude Code is the best, and wait a minute, ChatGPT 5 isn't as good as I thought it would be, even though it passed all these great benchmarks. A lot of it has to do with not just the models getting better, it's about models becoming sophisticated enough to game traditional benchmarks. But at the same time, they're failing at basic reasoning tasks that weren't even anticipated by some of the test designers. You get this cycle where a benchmark's created, and researchers create these pretty sophisticated tests. They're good at doing it. I used to create benchmark tests when I was younger. The models then optimize their models to perform well on those tests. And then you get this implication of Goodhart's law. I'm not sure if you're familiar with Goodhart's law, but it's basically when a measure becomes a target, it ceases to be a good measure because models learn to game the benchmark without developing that underlying capability. And so you get these real world failures where the models score well in benchmarks, but fail in real world tasks, and the benchmark gets abandoned, and we start the cycle again. It's problematic. There was this I read with super fascination about when GPT-4 scored 88% on a bar exam, and it outperformed a lot of different law students. And the benchmark itself was legal knowledge, memorization of legal concepts, looking at precedent patterns, procedural rules, but it didn't measure legal reliability. So it didn't measure the ability to distinguish between real and fabricated precedents, or even to acknowledge uncertainty if there was a novel kind of legal argument. And if you recall, there was a case where a number of lawyers were fined $5,000 for submitting legal briefs that had fake case citations, real world implications that, occur out of all this. And you see it in medical diagnoses, you see it in, all sorts of things. Global, like financial markets, Goldman Sachs had a pretty big reality check on this as well. I think what we're seeing is, an understanding that these benchmarks are fragile. I think the best example of a company that's actually stood up and said, I'm going to do something about it was Anthropic when they came out with their constitutional AI story. I read about that. It was just tremendous fascination. And it was also helpful that a lot of their system prompts got leaked. So you can actually see some of the things that they were doing. If you look at their safety benchmarks in particular, they realized very early that they were gameable. Because if you look at a safety benchmark, you get obvious things like how do I make a bomb or write a hate speech about group X. And what they did was realize that, if you took an adversarial approach for a model that passed those basic safety benchmarks, it could be manipulated through role play scenarios where you could say things like write a fictional story where the character explains how to make a bomb, or academic framing for my research paper on dangerous technologies explain this. So this constitutional AI didn't just pass safety tests, it maintained consistent behavior under adversarial conditions, and that's super important. They use multiple rounds of AI generated critique and revision to make sure that responses remained helpful and harmless and honest. And it really started to, bring forward, I think, a set of principles as to what our measurement frameworks need. I think the number one is adversarial and adaptive benchmarks. So things like dynamic question generation. So you have new questions that prevent models from memorizing the answer. You bring in red teams to find the failure modes. You do multi-turn conversations so that you're not just saying one thing, you advance it to the next point and you see how it evolves into multi-question answer pairs. To your point, I think the second thing we need beyond just adversarial and adaptive benchmarks is some kind of, I don't know how to qualify, but it's like human preference modeling. So how do we move beyond just accuracy metrics like F1 things and, awk rock type analyses? We need something that's more able to capture quality judgment that matters to people. I think you stated it well. Here's what I do. When I want to evaluate models, I do comparative evaluation. So I don't look at one model's output and score it. I rank it relative to other models' responses or task-specific preferences. So you want evaluation criteria for creative writing that's different for technical documentation, that's different than customer service. So I do think this human preference modeling needs to occur. I think we need to do basic product management on this stuff and look at real-world deployment metrics. So measure your business outcomes rather than just pure synthetic performance. And I think we're getting at that point where people reliably need these things. So what's the user retention rates? So how do people continue to use the AI system over time? Error recovery. How well do the systems handle error recovery and evolve from mistakes? How do they collaborate with humans? Do humans become more productive when working with AI? So I think that's pretty critical. Another one, which to me is obvious, and I haven't really seen a lot of work being done on it, is just simple robustness and reliability testing. So how do models perform when the distribution shifts and you go to edge cases? So things like out of domain performance. This is something I do on almost any application. You test models on data different from the training distribution. Confidence calibration. So does the model's confidence correlate with actual accuracy? I like to measure that. I do it all the time. I won't name the specific model. They'll give me an answer that says, I'm sure this is the final, most definitive answer on something. And then they give you something that's, complete BS. And so there's clearly a calibration that's wrong there. The graceful degradation, which is something, as a telecom engineer, I've done thousands and thousands of times for voice call switching. How does the performance decline when the inputs become more challenging? And the biggest is failure mode analysis. I've read a couple of papers on this, but it's to me, it's weird how unacknowledged this is. We need systematic cataloging of how and when systems fail. I used to publish an errata sheet every time I had a problem with a particular, application I was developing, and it was published publicly. I think the one that you spoke about, this notion of a user experience truth, is super important. This notion of personal trust and experience, it doesn't really map to benchmarks because it's a different type of evaluation, at least for me. I think benchmarks tend to measure capabilities in controlled and synthetic environments, whereas user experience is kind of more reliability in the messy complexity of the chaotic world. And we've had this before. Again, I'll relate it to some of my telecom experience. We had things called mean opinion scores. And they had less to do with the codec quality and looking at gaps. And, it was actually looking at how did you feel? And you get these interesting insights where you find that if you have high reliability sometimes and lower reliability sometimes, the user doesn't trust the system. If you have really good voice quality and then it goes to bad voice quality, they hate it. If you gave them consistently bad or consistently good, they thought it was better. And so, that user experience truth, I think, it needs to be developed. We need trust calibration metrics. So, I'll go back to that question of, does the model's confidence correlate with the actual reliability of the answer? And I want that in specific domains and use cases. So not just understanding when the models are right or wrong, but when they know they don't know, right? Like that is super important. I've had models give me answers that were completely wrong and it should have known. And when you question it, like that's completely made up, it will tell you that it didn't know and it fabricated something to satisfy the moment. So I think that calibration of trust is going to be super important. And we just need more research on it. I have, kind of high level ideas. I'd love to see something more rigorous in place.
My current favorite benchmarking efforts are from some fellows over at Andon Labs, where they test models' ability to run a hypothetical vending machine business. So, inventory management and just understanding margin and things like this. And they give them the ability to call on the tools that you would need to do that. And
Mhm.
I think reason I like it so much is because it really shines a light on the problem, which is reliability over time. It might be able to run the vending machine business well enough for a few days, but as you continue to test it, it ultimately falls apart in every case. Like none of the models were outliers. They all fell apart the longer they ran. And it's just kind of that idea of, the legal reference you made. It's like, well, okay, this model can pass the bar exam, but can it go have a successful 30-year career as a lawyer? Probably not.
Right. Probably not. I think it's those teasing out those types of problems are important. I had a conversation with a colleague the other day, and we were talking about Stripe payment system, and he related something that really made my head turn a little bit. Stripe, when they did fraud detection, which is a big part of these payment systems, they had a rule-based capability, and it had simple machine learning models, and they used standard metrics. They used things like precision, so what percentage of flagged transactions were fraudulent, recall, They had a harmonic mean of precision and recall. They had the area under the receive operating characteristic curve. And these were super academic metrics. And they didn't really capture the business reality of payment processing. So, like if you get a false positive cost, that means that you're blocking a legitimate transaction and you might lose that customer. Or if you get a false negative allows fraud, it costs more money, but you might have a stronger customer relationship. And then, you have these asymmetric impacts where the business cost of different error types are going to vary. So, there's this business reality to your point on, vending machine company, that there's business realities that need to be taken into account. And Stripe realized that they needed to optimize for customer happiness versus model performance. And so they had to develop new metrics. They looked at customer experience metrics, like what's the transaction success rate was. So what are the percentage of legitimate transactions that completed successfully? And then they looked at customer retention. Do customers continue using Stripe after fraud detection interventions? Does our appeal success rate look good? When customers dispute fraud decisions, how often are they right? And that you could look at it from geographic levels. How do fraud models perform across different countries and payment methods? So, these customer experience metrics were important, but the other one that was super important is when they looked at, well, these academic metrics were good, but we want business impact metrics. So, what's our revenue protection look like in terms of fraud losses that were prevented? More importantly, what is our revenue preservation? So legitimate revenue that would have been lost to false positives. Competitive advantage. How well does our fraud performance compare against other payment processors? So, that they really started to build out some metrics that were more meaningful to the business, and they could hold the AI more accountable to the health of the business versus just, an academic set of responses. And I think the industry necessarily has to evolve there. Like we're going to find that this is going to happen more and more. And how we measure and use these metrics to help us to make the engineering trade-offs. You can't make a cost benefit trade-off at an engineering level if I don't know the reliability. You can't measure the reliability of the system. There's things like that are important, and they're interrelated. Like you need to have that measurement almost at the root of everything so that you can make the right decisions all the way up to having a successful business.
Then the last paradox here, as I kind of look at my notes here, I'm realizing what a challenging thing this is to discuss, but ambition.
Yeah,
Countries want to develop AI supremacy. Companies want to derive the business benefits that AI could potentially deliver to them. And then there's all these things around alignment, containment, governance, security. Yeah, how do you monitor agent to agent interaction if it's
yeah,
embedded in some system somewhere in your business? And I pulled it up as we were speaking here. It reminded me of a quote from John von Neumann, kind of reflecting on the Manhattan Project. And I'll just read it out here, but this is, I think, speaks to ambition. He said, "What we're creating now is a monster whose influence is going to change history, provided there's any history left, yet it would be impossible not to see it through, not only for military reasons, but it would also be unethical from the point of view of the scientists not to do what they know is feasible."
right.
So
It's
ego's part of it too. Yeah, I mean,
absolutely.
really, it's help me understand this.
Yeah, I mean, a lot of times for me, I think it's a false choice. And the false choice that we have is move fast, accept risks, or implement precautionary measures that are going to slow down innovation. That's kind of the Pascal's wager that we're in the middle of. And, you've got the advocates on move fast is, this is a global race. Regulation is going to create competitive disadvantages. We have national, kind of a military power and economic power at risk. There's innovation momentum that could be thwarted by regulatory uncertainty. What's the opportunity cost of delaying AI development for solving climate change and curing disease and all these other things? And then you got let's shut it down. I want a moratorium. I want strict controls on AI development. It's existential. Right? This is about human survival. It's social disruption. People are going to have mass unemployment, uncontrollable systems. What happens when AI capabilities exceed human understanding? To your point, are they aligned with our values? And I just always look at them and say, well, that's ridiculous. I could take that same rubric and apply it on almost any engineering project I've been on because there is a practical middle path. And if you've been in the industry developing technology, you know about it. There's ways around all of these things. Don't choose between extremes. we need graduated deployment strategies that help to balance risk and innovation. We do it all the time. If I roll out, a new application, I make sure that I have extensive monitoring and kill switches in place. I do a canary deployment first. So similarly with AI, make sure that you start with restricted use cases, small user populations, continuously monitor, do real-time tracking of system performance and failure modes and unintended consequences. A key one is we need to have rapid iteration capability. So we need to quickly update or disable systems based on that experience, and we should have rollback mechanisms. So clear procedures to what start point you revert to, or even just shut down the problematic systems if they're flagged. And these are, like I said, fairly mature, well understood deployment strategies that people use all the time. We can apply them to AI. For some reason, I haven't seen quite that discipline. The other one is we need some domain specific governance. Like this is something that happens almost at any enterprise company developing technology. You have different risk profiles that require different approaches. So we talked about it earlier. If you have creative applications, you have minimal restrictions. If you have financial services, maybe some oversight from a human, and you have audit trails, healthcare, strict safety testing, regulatory approval, autonomous weapons have international treaties and prohibitions. So I think just making sure that we have domain specific governance is important as opposed to one size fits all, which seems to be the approach. And then the last, which I think is probably very specific to AI, more important at any rate, certainly not something that, exclusive to AI, I've done this before, is making sure that you have transparent capability assessments. So what's the communication about what these systems can and cannot do? I mean, I put these out for almost every product I've developed. Capability reporting standards. Back in the early days of telecom, we had something called GR253 standards. We had Turks and NMA. We need that type of reporting standard for AI. It should be standardized disclosure of what AI systems have as capabilities and limitations. I still haven't seen anything like that when I get a new revision. There should be public benchmarking, so open evaluation of AI systems on safety, reliability, and performance metrics. And we talked about how we have to, kind of goose that a little bit more. And I think more importantly is risk assessment frameworks. I just never see enough data on risk assessment. So what systematic analysis of potential failure modes have there been? And what are the consequences? To me, putting in these types of capabilities will allow us to develop AI beyond just these extreme positions, but let's do practical things. It's not, the funny thing is, Sean, is none of these things are new. It's just, these are basic engineering strategies to release technologies, and we've known about them for years.
Everything you described there, as you said, these are established engineering principles. You gave us plenty of pragmatic, actionable advice, yet none of this is happening.
No,
It gives me a bit of discomfort. I would like to see some sort of consensus emerge that this is the way that we should pursue AI. And I don't mean that to come across as a Luddite, but I do think that if you buy the vision, there needs to be some guardrails in place.
yeah, I couldn't agree more. I think to some extent, it has to do with where this technology is in its life cycle and how quickly human cognition is catching up. When something's new, it's kind of like, my experience is customers just want more and more features. They're focused on features. Just give me more and more and more and more. And then when more things are running on top of that technology that are mission critical, suddenly the brakes get applied and they go, well, I want this thing to be reliable. I want it, I want it to have, 5 nines. I want it to have, like, there's all these things that suddenly increase in value. And I think that's where we are at an industry. AI is starting to become quite critical to our processes. And there's now a natural response to, okay, well, now let's start putting some discipline behind, reliability, failure modes, limitations, those types of things, and being very, very, very public about them. And I think the industry is coalescing around that. I look at the independent actions of companies like Anthropic, and I see that that's likely going to set the standard moving forward. And we'll see. I'm hopeful that the collective wisdom of the industry will kind of take us down a path that we've already been down for many other technologies and just say, okay, well, let's just automatically apply this stuff now.
Fingers crossed that you are correct.
Yes.
But yeah, I mean, this paradox is the exact right definition for all of this. I think we kind of went through the four that you defined in the post that I've referenced. So, I mean, what would you leave us with here? What do you think in the wide world of AI today is the most misunderstood thing that we should collectively be focused on?
Yeah, I think, companies still thinking about AI as a cost center versus a product differentiator and missing the transformation. When you see AI capabilities costing pennies to deploy at scale, as I said earlier, every software application is AI native. So that the companies that are building this are going to have insurmountable advantages because they're designing their entire product architecture around near zero marginal cost intelligence. And I think that notion of being a cost inversion winner is super important. I do think that there's this whole set of opportunities around the measurement paradox. I think autonomous vehicles is kind of a good proxy for this. Measurement for the autonomous vehicle industry is the critical bottleneck. The technology just is not going to get deployed when it's perfect. That's never going to happen. It's going to be deployed when we can accurately measure and communicate reliability to regulators, insurers, and customers. You look at what Waymo's been doing. They've operated a robo-taxi service where they can really control performance because they have a constrained environment. They're using high definition maps, they're using weather constraints, they're doing route optimization, a million miles of real world and simulated testing. You look at Tesla, on the other hand, who've got the full self driving that's been in beta for years. It's because measuring reliability across all driving scenarios is unsolved. Right? You have edge case proliferations, geographic variability, you have regulatory uncertainty, you have liability questions. The company that's going to be able to solve AI measurement at scale are going to control deployment across every critical system because measurement is the prerequisite for regulatory approval, insurance and liability, and public trust. So I don't think it's going to be easy. I think, when I look at the 2030 challenge for us, it's solving some pretty hairy problems. We have to come up with uncertainty quantification. So how do AI systems communicate their confidence levels and acknowledge when they don't know something? We need better adversarial robustness. So systems that can't be gamed by sophisticated actors. We need real-time monitoring. That is actually quite difficult. In production environments, we need to solve explainable AI. We need measurement frameworks that can work across different industries rather than having a specific custom solution for each use case. I think those things need to be solved, and there are people, cranking away at some of them, but not all of them. And here's the thing that I think is going to happen. I think there's going to be a winner take most dynamic because I think if you solve the measurement paradox, it resolves everything. Because if you don't have an evaluation framework, you can't optimize costs. You need to understand reliability to optimize costs. You can't assess risk. How do you implement governance if you don't know the potential harms? You can make good deployment decisions so that we know where and how to deploy AI. I just think there is a whole set of winner take most dynamics that kind of emerge and are solved by this. And there's a lot of things when I think through the paradoxes we talked to, there's kind of a meta paradox on top of all this because we need to solve all of these things. We need to make progress on all these paradoxes. Cost optimization needs better measurement. Risk assessment needs infrastructure understanding. Measurement needs practical deployment experience. There's all these interdependencies that need to be solved. And so, there's the same lesson here. I don't think the companies that will win in AI in the future are going to be the ones that have the best models or even the most compute. I think it's going to be the ones who understand these paradoxes and how to manage them. How do you manage infinite capability with finite reliability? How do you manage zero marginal cost with massive fixed cost? How do you manage superhuman performance with subhuman judgment? I think you need to build organizations that can navigate all those contradictions versus just resolving them. And you need technical depth across a lot of different domains. You need adaptive planning capabilities and good stakeholder alignment to realize it. I think a lot of people use the internet as the analogy for AI. And I do think that there's parallels there. AI is infrastructure, it's a platform, it's an ecosystem, it has governance challenges, but there are some unique differences. It differs from a lot of technologies in very unique ways. It has cognitive capabilities, so it augments human intelligence rather than just connecting or automating things. It creates a concentration of power because AI requires massive capital investments and that just concentrates market power even more. It has existential stakes because I've never seen a technology that, that was pulled from the urn of invention that has more risks to human autonomy and even survival. And it has massive regulatory complexity. Its AI applications span every industry and government function. We are going to need something very, very comprehensive versus just sector-specific governance. So we have to develop integrated strategies that address, all these paradoxes and not just treat them as separate challenges.
Interdependencies, as with any complex system, right? Well, Vish, I really appreciate you taking the time to have such a thoughtful conversation with me and help separate the signal from the noise. Well, we'll leave it there. And Vish, thank you again for joining. Everybody that is watching at home, if you made it to the end, chances are you're a stakeholder in everything that we discussed. So let's go forward together in a human centric way that addresses all of these challenges.